To begin this section, we need to review some vocabulary from earlier in the year. First, we need to distinguish between an expression and a term. An expression is a formula or a calculation that may contain variable and/or constant terms. On the left-hand side of the yellow box, you'll see examples of some expressions. Notice that they are not set equal to anything, and so you can't solve them. You can plug in different numbers for the variables in expression and evaluate what that expression would be, but you can't solve it. Terms are the parts of an expression that are separated by addition or subtraction. So for example, in the expression 5a cubed minus 2xy plus 3, there are three terms. 5a cubed is the first, 2xy is the second, and 3 is the last term. I'll often refer to the terms as the different chunks of an expression that are added or subtracted together. An equation is just an expression that's been set equal to either a specific value, like a number, or to another expression. Equations may have one solution, for example, x equals 2. They may have several solutions. We'll work in this unit where there are two solutions to a given equation. They might have infinitely many solutions, or they might have no solution at all. A solution to an equation is a set of values, that is, numbers that we plug in for the variables in the equation that make the two sides of the equation be equal to each other. Now let's get into the meat of section 9.1. First, some more vocabulary. The first term we need to define is monomial. If you remember from our work in chemistry, that prefix mono means one. Mono is one. So a monomial is an expression that has one term. An example of a monomial would be 3x squared. This is a single term. There's nothing else added or subtracted to it. It is an expression. It's not currently set equal to anything. So this is a monomial expression. A binomial, bi means two. A binomial is an expression with two terms. An example of a binomial is 3x squared plus 2x. There are two terms in this. The first is 3x squared, and the second is 2x. A polynomial, the prefix poly, just means many. A polygon has many sides. A polynomial has many terms. An example of a polynomial is 3x squared plus 2x plus 3. In this case, it happens to be a trinomial. It has three terms. A polynomial could have 2 or 3 or 4 or 100 different terms. Poly simply means many. The degree of a polynomial is something that we'll find by looking at the largest exponent on the variable. For example, here's a polynomial, 15x minus x cubed plus 3. If I wanted to know the degree of this polynomial expression, first I'd need to find the degree of the individual terms. The first term, 15x, has a degree of 1. Remember that there is an exponent of 1 on the x in that 15x expression. We just don't normally write it there. The second term has a degree of 3 because the exponent there is a 3. The last term has a degree of 0. We could write the last term, 3. We could write it as 3 times x to the 0. Remember, x to the 0 is another way of writing the number 1. Now we know the degrees of the three individual terms in this expression. The degree of the whole expression is simply the highest of these three degrees. The greatest degree in this case is 3, so the degree of the whole polynomial is 3. Normally when we write polynomials, we'll write the terms arranged with the highest degree one coming first and the lowest degree one coming last. This will be helpful as we go to add and subtract polynomials and when we start to work with polynomial equations and solving them. We call the leading coefficient the coefficient that comes in front of the term with the highest degree. When we write our polynomial with the terms arranged from the highest degree to the lowest, the leading coefficient will be the very first coefficient in that series of terms. The leading coefficient for the equation shown above is -1. because the middle term, x cubed, has the highest degree, and the coefficient on it is -1. Now we need to look at how we can combine polynomials together. When you think in the past about combining like terms, we couldn't combine the variable x and the constant 3 in the expression shown below. X plus 3 wasn't equal to 3x or x divided by 3. Those two, x and 3, were unlike terms, and so we couldn't combine them. Similarly, when we have terms of different degrees, we can't combine them together either. So here's an expression, 15x minus x cubed plus 3. There's no combining of terms that we can do here because these three terms all have different degrees. They are unlike terms and they can't be added or subtracted together. It is okay to combine terms that have the same degree. For example, in the equations shown below, if I have 5x squareds and add to that 6 more x squareds, I have a total of 11 x squareds. Because these are both second degree terms, I can combine them together. Notice that the exponent didn't change, and the words that I used, I said I added 5 x squareds to 6 more x squareds to get a total of 11 x squareds. I'm not multiplying terms together, so I don't need to do any adding of exponents. I'm simply counting up in total how many x squareds do I have here. Here's another example that you may have seen in the past. If I had 15 x's and added 2 more x's to it, I ended up with 17 x's. This is simply an example of combining terms with the same degree.